131, right? The minimum falling path sum, in which it is saying that given n cross m array of integer matrix, return the minimum sum of a falling path through matrix, right? So a falling path start at any element in the first row and choose the element in the next row. So either directly below or diagonally left or right. So especially the next element from the position, right? If the position is row and col, right? So it will be go to row plus 1 or col minus 1, right? So it will go to the next row. It, if this is the row, so he can go to the next row, but he can go if he is here, right? So he can go what? Column minus 1 means this one, or either he can go column plus 1, right? So he can move like that. Okay, so you can see in this example that from 1 he is going to either the same position, right? So right, row plus 1 and column plus 1, or a column minus 1, or in column plus 1 or equal to, then he is coming to this column minus 1. So this way, if either you have to go to straightly down, right, directly below, okay, or either you go below, diagonally left means this one, diagonally means left this one or this one, right? But it should be minus 1 or plus 1 either, right, from the column or dash one. Okay, this is another example, right? So now because this is a 2D matrix, right? So there is multiple approaches that we can do to find the minimum falling path sum. Okay, so if we will understand about the overview, so given 2D matrix, we have to find the sum of minimum falling path in the matrix, correct? So to begin with, let's understand what is a falling path, right? So put in the simple word, it is a path that satisfies the following criteria. The first is a falling path is a path that begins at any cell, right, in the first row of the matrix and ends at any cell in the last row of the matrix, right? If it start from here, right, if it starts from the first row, right, this one, so what will happen? Like any cell, like this one or this one. So if we'll consider for this one row and column, right, in this row, so if you'll go to the last row, right, so he can go to row plus 1, row column minus 1, row plus 1 column, or row plus 1 column plus 1, right? So it is saying that we can move only to 3 possible cells, right? Either this or this. If the matrix is bigger, right, there is a possibility to have here another column and in the left or right, both side, right? So but he can go only these possible possible cells, right? He can move only 3 possible cells: row plus 1 column, row plus 1 this one column, row plus 1 column minus 1, row plus 1 column minus, left, right, or straight down, right? I think you have understood very well. So as the name suggests, the falling sum is the sum of values of all the cells in the chosen path. So our goal is to find the minimum sum of all the possible paths, right? So let's consider the different approaches that can be used to solve this problem. So we will begin with the brute force and optimize it using the dynamic programming and so on. Okay, so let's begin with the approach 1, that is a brute force using the depth first search, DFS. So brute force is generally the straightforward approach to solve any problem, right? So what you can think of the brute force approach is, so if take a pen and paper in your hand and you will try to solve the problem, right? That's very easy. Though the brute force approach is considered to be the most exhaustive and unoptimized way, it means sometimes the Leetcode will give you time exhaust error, right? And so that while implementing this approach, first given a deeper understanding of the basis of the problem, which further help to shape a better optimized solution, right? So why I am always going with the brute force, right? This is not recommended, but we should go for because you will understand the problem in depth, right? So let's understand brute force with this example. So if this is the matrix, right, 3 into 3, right, total 9 cells are there, right? So we have 0 0 0 1 and 0 2, in which we have 2 1 3. Similarly 6, 5, 4, 7, 10, 9, right? These are value we have. So in this example, if we'll start at 0, 1, right? If we'll start from here 0, 1, the next cells in the path would be what? This can be what? 1, 0, right? This can be 1, 1, or this can be 1, 2, like this one, or this one, right? So we cannot determine which path will give the minimum path sum. Okay, so what we will do, we will try all the possible path, like this path, or this path. How many possible paths we have? 3 possible paths we have, right? And we will find our what? Current path sum. So current path we will calculate here. 1 plus 6, what we have? 7 here. If we calculate this one, 1 plus 6 is what? 5 here, and 1 plus 4 is what? 5 here, right? Yeah, so here 7, 6, or 5, right? Total. So as you can see that this path is giving what? Minimum 1 plus 4. So the minimum path from cell is what? 5. So going from what? 1 to what? 1 to 0, 1 to what? 1, 2, right? We have 5. Does that mean that we greedily choose this path, right? We will choose this path and move ahead, discarding, or we will discard this path. So let's find the falling path. If we choose the path 5, that is right, we will come what? 0, 1 to 1, 2, right? And if we will go to this path, right, there is now, if we are here, so two paths are possible. Two paths is here. Either we have to go here, or either here, because in the right part we don't have any cells, so we can't move to here, right? So column plus 1 is not possible, right? But column minus 1 is possible, and the same column plus 1 is available here, right? So you can see here that we can move here to here, and we are here. But when we move to here and here, we have to see that if we will choose, right, 10, right, what happen? We will get 5 plus 10 is 15, but if we'll choose this one, we will have 14. So this is our minimum path, correct? So thus the minimum falling path is 14, and now let's explore the other path, starting from what? 0, 1 to other, right? So if we'll start from here, and we are not choosing this one, we are choosing this one, correct? Now we are choosing this one. So we have 0, 1, now we have 1, 1, right? So 1 plus 5 is what? 6, and then we are going to this path. We are not going this path or this path. We are going what? This path, correct? This path. We are choosing this path after 1, 1. So we got what? 7. So now what we have? 13. If we are going with this path, right? We are getting what? 14. But now we are getting what? 13, correct? So it is better than previous one. Now if we'll consider this one, we are not going 5 and 4, the straight down and the right down, right? We are going left diagonally. So from 1 and 6 we have 7, 1 and 6 we have 7, and next is 7, that is 14, that is also 14. Okay, so as you can see that the minimum falling path is now what? 13, that we are going from 0, 0, 1 to 1, 1, and then to 0. It means this proves that the greedy approach will not work for this problem, correct? So a subpath, the subpath will the lowest subset sum cannot guarantee the lowest sum for the entire path. So we must explore all possible path to find one with the smallest sum. So since we have to try all the path from any cells, the solution must generate all the possible paths, falling path, and track the one with a minimum sum. So if we try to try to all possible combination, all combinations, we can perform DFS, right, on the matrix, because in the DFS we can go to from top to down, and it will give you what? All possible combination. We will do that. So the DFS is an exhaustive search process, right? So where we will traverse all the cells in the path, right? So on reaching the end of the path, we must undo our last steps in the current path, and we try different possible next step to extend the path. So we have to take some note here. This note is the approach is a brute force, right? And it is not expected to pass all the test cases. So this approach is included because often an intuitive way to approach problem like this. Want to start by building a brute force solution and then modify it to achieve an optimized solution. So algorithm is right. What algorithm we have? We will implement DFS algorithm by defining a recursive function. So we will take a function that is name is find mean falling path sum that will take column and row and column. Then recursively explore all the path from the current cells, right, and define by row and column. So define base case, right? We will define base case in any recursive function. We define terminating condition in the base case. When terminating condition is satisfied, we will exit the recursive search process, and the base case are as follow. Row and column values are not within the matrix boundaries, and we have reached last row. So in this case, we will return the value of the current cell and not make any other recursive call, because we are at what? Last row. We do not need to go down, right? So recursive explore all paths. Okay. So if the base case is not satisfied, it means that we have not reached at the end of our current path. So we must try all the options to extend our path and find the one with the minimum sum. Now understand again. What we will do? We will do DFS, right? We will do DFS with the recursive function. Okay, that will take row and column, and we have to explore all the path from current cell to the down, right? So we will take a base case and we will define base case in the sense like if we will reach at the bottom, we will not do any recursive call, correct? Because that is our boundaries, right? That is our boundaries. We do not need to do that. So recursively we will explore all the path, correct? So if the base case is not satisfied, we have to do recursively call. To make sure, we will do these two, right? And we must try our option to extend our path, all the possible paths, right? So we will find with the minimum sum if we will reach there, right? So how we will find the minimum path, correct? So minimum path is minimum, and we will row plus 1, column plus 1, row plus 1, column, row plus 1, column minus 1. So this will give you the minimum, right? This will give you a minimum, okay? And that is our minimum path. Now that we have defined the recursive function, and we must find the minimum falling path for all the starting cells, right? What we have to do? Because we have already minimum path, right? So we have defined a recursive function, and we must find the minimum falling path for all possible starting cells. A starting cell is any cells in the top row, right? In the start in the top, yeah, either that is at 0 0, at 0 1, or maybe next. So for this we have to iterate using a for loop to find minimum falling path for cell in 0th row, right? So column starting from 0 to matrix length minus 1 will define minimum falling sum to track the minimum of all the falling path sum so far, and it will return what? It will return result. Let's see the program. You will understand very well. So our approach is to traverse the till down, right? So if we'll call about this one, right? Let's see first this function in which we will find mean falling path sum, right? So mean falling path sum is, we are taking what? Matrix. We will take int row and column. We will row and column matrix, right? Correct. We'll do some base cases, right? So what if column is less than 0? If column is less than 0 and column is equal to matrix dot length, it means we are at boundaries. So we have to check if we are out of the left or right boundaries of the matrix. So if column is less than 0, right, it means we are at boundaries, right? We are at left boundaries, okay? And if column is equal to length, matrix of length, means what? We are at the right boundaries, okay? In that case, we will return integer dot max value. That is our max value, okay? Integer max value. Now if we have reached the last row, how will find that? If row equal to matrix dot length minus 1, correct? So if matrix dot length minus 1 we have is equal to row, right? Row, we have reached the last row, right? So we will return matrix row and call, okay? Whatever the matrix row we have and the column we have, that we will return, because we have to check if we have reached the last row, correct? So these are two base cases that we have to take care of, right? Finally, we will calculate the minimum following path, that sum starting from each possible next step, right? We will calculate left, middle, right, because either we will go to left, we will go to the middle for the straight down, or we will go to right. So left is for left diagonal to go on, sorry, possible path. Left is left diagonal possible path, or middle is the directly middle diagonal path, and right is right is right diagonal falling path is a possible way, right? So these three possible paths contain the three variables, and that will get the minimum path, right? That will take minimum following sum path, right? So we are passing what? Matrix row plus 1, row plus 1, column plus 1, row plus 1, column minus 1. These three that we have discussed already, right? We will return how? We will return minimum. How we will do minimum? Left, minimum of left, because this is Java, right? In Java we will take only two arguments. So we will take left, or the similarly middle and right. We will take middle and right as a one, in which this is whatever the minimum is here, that will come here, and left we have, right? So in this we have already got from these two the minimum, and now left is there, right? So this we will return the minimum of left, middle and right, whatever the minimum we have here, that will come here, plus matrix row column, that we will have the previous data, right? Previous value we will come from what? Matrix row and column, correct? Similarly, this is our recursive function, right, that we have discussed. Now we will call this recursive function what? From we will start from 0 to matrix length for all the starting column to ending column, right? We'll go through the mean following sum. We will calculate, we will take maximum integer value, and because why we are taking maximum integer value? Because we have to take minimum value, right? Whatever the minimum value we have, that's why we are taking maximum of integer, right? Max integer. So we'll take minimum following sum, and the minimum following sum is what? This is a max integer value that we have, and we have to pass matrix, and the matrix, what we can say, the row is starting row is 0, and the starting column, so from where we have to start, right? And then this is the value, this is the this will find the minimum following path sum, and it will return, and whatever the minimum value we have, that will call as a minimum following sum, and we will return mean following sum value here. Okay, I think you have understood. So let's understand what we will do. First, we will take a recursive function that will take row and column matrix, and that will we have to take to we have to check the base case for the boundaries, right? When boundaries condition, if we are at boundaries, we have to return the max value, and if we have reached the last row column, right, that is our other base case, that we will return the row and column values, right? That means we have already calculated the value, and we will return that. And after that we will find left, middle and right, and in which whatever is the minimum, that we will return, and this minimum will return by using the for loop. We will calculate the mean following path, and we will return the mean following path, right? So in this way, this will our brute force approach, and in which we will do that we will do brute force approach, and we will do the solution. Now understand the complexity analysis, right? What is the complexity? As you can say that the solution takes three recursive function, right? We are doing three possibilities for the every node in the tree, right? So this time the complexity can be derived as follow. Why? The minimum path, the minimum depth of the recursive tree is equal to the number of row in the matrix, correct? Each level, right, each level of the recursive tree will contain approximately third node, right? Third level node. For example, at level 0, what we have? 3 nodes we have, right? And for level 1, and 1 node, and so on, right? What will be what? 3 to the power n, right, for each level. Thus we can say that n into 3 to the power n, and that's why this is our time complexity, O n of n dot n into 3 to the power n, correct? So the time complexity is exponential, hence the approach is exhaustive, and result will be time limit exceed in the program. But we are talking about the space complexity, so the space is O of n. This space will be used to store the recursive stack, right? We are using a recursive stack, and we are storing the data. So as the minimum path of the tree is n, we will not have more than n recursive call, the stack call at any time. Okay, so this is the program we have. Now we will going through to understand, we will go through the approach 2, and we will see that top down approach, right, in which we will see that dynamic programming, right. So brute force was what? Exhaustive, right? So to come up with the optimized solution for the problem, let's take deeper look at the recursive tree. If this is the root, what we have, we'll take 0 0 0 1 or 0 2, right? Right? Because we are finding what? Finding minimum path sum, correct? So this is the function, the find minimum path sum. We are passing 0 0 0 and 0 2, because if we have three possibilities, correct? Now the minimum path is, if you calculate for this position, right, we have to go with 1 0, right, or 1, correct? If we have 0 1, we will go to 1 0 1 1 1 2. Similarly, if we have 0 2, we go to 1 1 1 2, and similarly the and so on, right? So in this lesson tree, we can identify the repetitive what sub path, correct? The circle in the color. You can see this function, right? This one, the repetitive, right? So find mean path sum 1 0 is calculated twice, right? So find minimum path sum 1 0 is calculated 3 times, and so on. Give me a minute. Okay. So the repetitive calculation of the same subproblem is calculated through what? Using the subproblem, right? So repetitive calculation of the same subproblem is root cause of the exponential time complexity in the previous approach, right? Although, what if our algorithm could remember the result of subproblem when it computed the first time and reuses the stored every time, right? If we have some storage thing, right? Like we have array list, you can say, or array, right? That will result of this one. So if the second time it is going to get here, we have already this one, so all these calls will not require, right? This all the calls is not required, and so that no calculation is required, right? Here is no calculation is required, here is calculation is required, right? In this manner, what will happen, we will get better time, right? We will optimize our time, correct? So pretend you are at a treasure hunt on reaching point A, correct? And reaching point A, you travel to the destination and you don't find anything there. You go back to some other path, which again takes you to the point A. Wouldn't explore the same path from point A again? You would say, I have been here before I know where this path goes, correct? So means you have already calculated this one. No need to calculate again, correct? And this is why this is called top-down approach, correct? So in programming, right? When a recursive recursive problem solves the sub problem multiple times. Okay, so it has the overlapping subproblem property. Such problems can be optimized using a dynamic programming technique called memorization, correct? What we will do, if the subproblem is already calculated, we will store the subproblem solution result into a memory. Okay, that memory will and will return if required is with the same subproblem is coming next time. So we do not need to calculate because we are already stored in the memory. Okay. As in the previous approach, each call to find minimum path return the minimum falling path sum between the current cells and the bottom of the matrix. Okay. Let's understand the algorithm, in which we will see that if we'll pass the parameter and we'll revisit the subsequent call, then it will reuse the stored result, right? How we'll do that? So algorithm is saying that in order to record the result of the computation for every cell, maintain two-dimensional matrix that is called memo, and that will contain memo value, right? Row and column value, and would give the result falling from cell row column. Okay. So next thing what happen, if we implement a depth DFS by defining a recursive function, right? So it will recursively explore all the path from to the given row and column. Okay, base case remains same, right? So base case, in a recursive function we must define terminating condition, the base condition. When terminating condition is satisfied, we will exit the recursive search process. The base cases are what? Row column value are not within the matrix boundaries, and we have reached the class. The same, correct? And recursive will explore all the path, and if the base case is not satisfied, it means that we have not reached at the end of our current path. So we must try all the possible options to extend our path and find minimum sum. What? This is the function that we have discussed already, right? Row plus 1, column plus 1, row plus 1, column row plus 1, column minus 1, and this will give you the minimum. Now step 3, to avoid repetitive computation of the result, the brute force approach, we may use store result, right? So here, this is our, the step 3rd will store our what? We will take a memo array, 2D array, and will store the result of the given row and column, right? Okay. So before recursive computation, the result of the current cell, check if the memo has the result of the current cell. If so, we will return the result. Otherwise, we will proceed with the recursive call to compute the result. Right. Okay. So after computing the result, what will happen? We will store the result and in the memo. And if next time we will come, we will return that. Okay. Iteratively, we will find in the step 4. Iteratively find the minimum path, minimum falling path for all the possible starting from cell 0th row and column ranging from 0 to matrix n minus 1. Okay. And we will track the minimum value. The value variable is mean falling sum, and we will return the result. Okay. So let's understand the program here. Similarly, we will do here. What we will do here, we will take the recursive function, okay, row, column, and pass memo. Array that will 2D matrix that will, right, and that will store our result. Base case will remain same, correct? Base case will remain same. One extra we have to add in the program, that is this one, right? What we used to do, we are not storing the value, right? So if the stored value is already in the row and column, what we will do, we will return that value. Means we have to store here, so we are storing here. We have calculated the minimum, right? And we will store what? Row and column in the memo. Okay, and return memo. All things are remaining. We have to add what? Memo of this, right? And if the memo ends, otherwise we will store the memo. Okay, and in here we have to define memo, right? And if the minimum value we have, then return minimum, right? Correct? We will return. Okay. So in this case, if you'll talk about the complexity, right? Complexity is O(n) square, and complexity will remain O(n) square because we are taking two extra spaces, right? Why time complexity O(n) square? Because for every cells in the matrix, we will compute the result only once and after the memo. So for the subsequent call, we are using stored result that takes O of 1 times. Therefore, n square cells in the matrix n square DP state, correct? So that time complexity is n square. And about the space complexity, why the space complexity is square? Because the recursive call stack uses O of n space. As the minimum depth of the tree is n, we can't have more than n recursive call on the call stack at any time, right? So the 2D matrix memo uses O(n) square space, thus the space complexity will what? O of n and O(n) square, and that will come O(n) square, correct? So in the last program, what we have seen, we have not used this, we were not storing somewhere, that is called the minimum value that we have calculated left, middle, right, whatever the minimum we have, that will we are not used to store in the memory, and that we are not in the memory, right? But in this case, to do, we have to take only extra storage, right? That is called memo as a matrix, and that matrix right? That matrix will store, we will pass this into the recursive, and recursive will store our memo. And if the memo is not, means what, we have the data, we have already stored the result, and we do not need to uh, go further to calculate, right? So we have to take care only these memorization thing. That is our approach. Secondly, we have bottom up. That was our top down approach, but this is our bottom up approach that we will see in the next program, right? And uh, as you can see that we are doing from top to down approach, but this is our bottom approach. It means we will start bot. So stay tuned, and we'll come up with another video other part, because this video will become very lengthy. Well, okay, so we'll talk about also the space optimized bottom up dynamic programming. And finally, thanks so much to be here, and please like, share, and subscribe the if you like this. And if you want to do some follow-up questions, this is our follow-up questions on the Leetcode. You can go through and you can work on the minimum falling path sum. Thank you so much, guys.